Right, we're going to cover Module 5, the parts that most people struggle with, and we're just going to do some examples, and maybe that will help you, but please feel free to get in touch with me. We'll work together. All right, so let's just talk about the molar mass of elements and compounds. You will need a periodic table to calculate it. It's pretty easy. So if you were to look at the molar mass of carbon, you go to the periodic table and you find carbon. Carbon has an atomic number 6, which is not what we need, and it has an atomic weight or atomic mass of 12, and that is what you use. So when we say, what is the molar mass of carbon, we basically are using that number here, is the 12. So 12 grams per mole. That's it. It's as easy as that. So if we were to calculate what is the molar mass of H2, we would go to the periodic table, look for hydrogen. It's a little tricky because it has 1 for the atomic number and 1 for the atomic mass. So let's just say 1. And so because there's 2 of them, it's basically 2 grams per mole. All right, we just write mole like that. Okay, what about H2O? Okay, we say that we already know that the molar mass for hydrogen is 1 gram, and there's 2 of those, and we just have to find oxygen. So we go and find oxygen. Let's round it to 16. So we put 16, and we add those together to get 18 grams per mole. That is really all there is to calculating molar mass. And we're going to use that as a conversion factor when we do stoichiometry. All right, so let's just talk a few little simple things to kind of demystify this whole situation. Now, we are going to use those molar masses as conversion units. And so, and we're going to make them look like fractions, so don't let that throw you. For example, you already kind of are used to doing this. Like if I ask you how many minutes are in a year, you could do it in your head. But if I were to like write it down and technically do it, you would basically, this is getting kind of fuzzy, write it as a fraction and multiply it by the conversion unit. So we'd have to figure out what conversion units we could use for a year. I think we can figure out how many days are in a year, because there's 365, and then per 1 year. And then we have to go from days. What can we do? I think we can figure out how many hours are in a day. I'm trying to hold the camera, sorry. And then you can go hours, minutes, and there's 60 minutes in an hour, and then you'll do the math. So basically first let's get rid of the units that are gonna cancel, and then you'll take 1 times 365 times 24 times 60 divided by 1 divided by 1 divided by 1 divided by 1. Obviously you won't divide by 1, but you get the idea. And that is 265, 600 minutes. All right, I think there's a song. All right, that's it. And so that's basically converting, using conversion factors that you're pretty familiar with. So that's all we're doing when we're using these molar masses. They're just conversion units. It's just a little bit different. All right, so let's talk about some ratios with something you're familiar with. So let's say you found this cookie recipe, and these ingredients will make 48 cookies. All right, this is like your reactants, and this is your product. And these are the ratios in which we have to work with, because it might be that we don't have everything. We might only have 1 egg. And so we know that that would not make 48 cookies, but would make 24 cookies. You just did a ratio in your head. That's all we're doing with stoichiometry. And the thing that makes it a little tricky is that we have to convert units. So let's just make it a little bit harder, and let's just say that we have 2.5 milliliters of vanilla. But our recipe is in teaspoons of vanilla. So we have to find how many milliliters are in a teaspoon or vice versa. So I looked it up. And so we can use this as conversion unit. All right, so let's just, I think I did this already. So you start with what they give you, which is 2.5 milliliters of vanilla. You're going to multiply that by the conversion units. Just remember, it could go 1/5 or 5/1, but what you need to make sure of is that the unit that you're going from is on the bottom so that they cancel out, and you'll end up with teaspoons of vanilla. So you're not going to actually need to do the math, but you can at that point say, okay, in my recipe, I have this ratio. So there's like 2 teaspoons for 48 cookies. And when I do the math, that tells me I can make 12 cookies with 2.5 milliliters of vanilla. This is exactly what we're doing in stoichiometry. We're having to convert to something that shows up in the recipe. We take the ratio from the recipe, and then we're ending up having to cancel out units, and we take everything at the top and multiply it and divide it by everything at the bottom. And I know that that's quick, and we're going to do some examples, but that's basically what we're doing when we do stoichiometry. It's just a little bit unfamiliar to you. And so let's do a practice one. I like to start with the one they use in the lesson, which is if you take hydrogen gas and you add oxygen gas, it will make water. So this is not a balanced equation, so the first step in stoichiometry is you have to balance the equation. I'm going to assume that you know how to do that, so we'll just balance it. Okay, perfect. In a stoichiometry problem, let's say we have 10 grams of hydrogen, and the question is, how many grams of water will that be? So the first thing that you're going to do is you start with what they give you. And they gave you 10 grams, sorry, I'm messing. They gave you 10 grams of hydrogen. And just make it look like a fraction, it'll just work out better. You're going to multiply that by the molar mass of hydrogen. Is going to go right here. So just remember, the little cheat is if I say grams of hydrogen here, just put grams of hydrogen here. And then you can kind of think about it. I'm going to put moles of hydrogen because that's what my molar mass was. I think we did that already, and we said that the molar mass is 2 grams for 1 mole. And then we're going to multiply that by the ratio of hydrogen to water that's in the equation. You can say this balanced equation is 2 moles of hydrogen plus 1 mole of oxygen gives 2 moles of water. So that's just kind of how simple moles are. So the relationship between these two things is a 2-to-2 relationship. So we're going to just put that in there. So remember, if you've got moles of hydrogen here in my ratio, I'm still going to put moles of hydrogen here. And then that relates to moles of water. And what is the ratio? Is a 2-to-2 ratio. This is the hardest part to remember to do, I'm just telling you, because this is something that's a little bit different than what you're used to. All right, so if you were to solve this, your answer would be in moles of water. You need it to be in grams, so we need another conversion from moles of water to grams of water. So we're going to multiply it by the conversion. Moles of water, grams of water. And I think we did the math already, and I think we said 18 grams are in 1 mole for water, remember? And then now we're ready to solve. Now, remember, when you divide something by itself, it cancels out. So we're going to get rid of all the like units, and it also will help you make sure you set it up correctly. And so that's going to end up with an answer in grams of water. So let's do the math. You have 10 times 1 times 2 times 18 divided by 1 divided by 2 divided by 2 divided by 1 is basically what you can put in the computer. The calculator. But obviously you can factor out some things. If you're familiar with factoring, it's real handy. But if you put it in the calculator, it ends up being 90 grams of water would be your answer. And that's all the stoichiometry problem is. All right, now we're going to do a limiting reactant. And all a limiting reactant is it gives you two quantities, and then it's going to ask you what's the least amount of your product. So let's say that we have 64 grams of oxygen. How much water can be made if you have 10 grams of hydrogen gas and 64 grams of oxygen gas? And so what we have to do is we do two stoichiometry problems. We do this and we figure out how much water is produced. And then we do another problem and you take 64 grams and you figure out how much water is produced. And whichever produces the least amount is your limiting reactant. So since we already did this one, we came up with 90 grams of water. So now we're ready to do this one. So remember, start with what they give you. They gave you 64 grams water, make it look like a fraction. We're going to convert from grams of oxygen to moles of oxygen. And remember, we said go to the periodic table, and remember oxygen is 16, but because there are 2, we put 32. Okay, let's just talk about that a second. Oxygen is 16, and O2 is 2 of them, so we put 32. All right, now we're going to do the mole to mole ratio. That's the hardest part to remember, but the easiest part is you still going to take that. There we go. Moles of oxygen. So we go up here and we say the moles of oxygen ratio between moles of water is a 1 to 2 ratio. 1 to 2 ratio. That comes from the balanced equation. So we're going to have a 2 at the top and the 1 at the bottom because we know the oxygen's at the bottom. Okay, the last step is we're going to convert to mass by using the molar mass of water. And that, by the way, is going to be the same as what you did up here. So you got moles of water, grams of water. There's 18 grams per 1 mole. That should give us grams of water. Bear with me. Take a deep breath. Okay, so make sure you cancel out your like units, and that way you know you set it up correctly. You take this 64 times 1 times 2 times 18, divide it by 1, divide it by 32, divide it by 1, divide it by 1, and that will get you 72 grams of water. This is the least amount. Therefore, oxygen is the limiting reactant. Limiting reactant. And that's all limiting reactants are, is you take two stoichiometry problems. Okay, now